Hi, and welcome to our latest tips and tricks tutorial. In this episode, we're going to demonstrate that Forest Pack isn't just for plants. It's also well suited for adding furniture and characters to the interiors of large buildings to quickly fill a huge area over a number of floors. Instead of painstakingly placing thousands of objects, let Forest Pack do the heavy lifting for you and scatter random types of furniture on each floor plate. In this tutorial, we'll share a collection of techniques for populating building interiors, focusing on 3 possible scenarios. Firstly, adding furniture to buildings where each floor plate is a separate object. Secondly, we'll look at adding furniture to buildings where the floor plates are combined, and separating them would be too much work. At the end, we'll look at how to create the floor plates using RailClone and examine how Forest Pack and RailClone can work together to create a fully parametric system that includes facade, floors, and furniture. So back to scenario 1, where the floor plates are separate objects. To use this mode, you'll need to add each individual floor plate to Forest as a separate surface. Adding each floor separately retains most of Forest's features and is very easy to use. So to get the tutorial rolling, let's create a Forest Pack object to scatter the desks, the chairs, the computers, and other furniture. Go to the Create panel and create a new Forest Pack object by clicking on the surface called Individual Floor Plates. Then go to the Modify panel and open the Surfaces rollout. Using this rollout, we can add and remove surfaces as well as controlling the modes, alignment and limits based on altitude and slope angle. For now, we just want to add the remaining floor plates. So to do this, click on Add Multiple and then select the objects in the scene named Individual Floor Plates 1 through to Individual Floor Plates number 36. Once you've done this, you should see objects scattered on each floor of this building. With the surfaces successfully added, we want to assign the scatter items. To do this, open the Geometry rollout and click on Add Multiple. From the Add Multiple list, select the groups named Desk Empty, Desk 1 Person, Desk 1 Person 2, Desk 2 People, Drawers, Storage System, Table, and click Add. For this tutorial only, I'm going to turn on Update Auto. This will ensure that the Forest object updates live in the viewports as we edit the surfaces. So with that done, let's go to the Distribution rollout and change the map type to Full. Adjust the density until the scattered objects are no longer overlapping. This will give you a grid-like layout that works well for furniture. If you prefer, you can experiment with other map types to give you different results, but don't be put off by the sheer number of objects. We'll be randomly removing some of them in the next step. So as you can see with this setup using the full map type, the distribution is very dense. So in the next few steps, we'll scatter a null object and adjust the probabilities to add some gaps to the furniture layout. So go back to the Geometry rollout and click on the plus sign to add a new item. Rename the item Null and set it to Disabled. Disabled objects do not display geometry, but they still contribute to the scatter calculations, leaving a space wherever one occurs. So this creates a few spaces, but we'd like more. To do this, we can adjust the probabilities of the objects. In the items list, select all the objects except the null and change the probability to something low, about 15%. Note that the values are automatically normalized. There's no need to manually ensure they add up to 100%. You can also adjust the balance using these settings. For example, if you wanted fewer empty desks, just lower the desk empty items probability. Now if you look at each floor, you'll notice that the objects, their distribution and any randomized transforms are exactly the same. Fortunately, this is easy to fix. Just open the Surface rollout and turn on Randomize Stacked. This will randomize the transforms and scatter items for each layer. Note that it doesn't randomize the position of the distribution map, but because we're creating spaces by using a full map and adding randomly placed null objects, we achieve a similar effect. If we look at the resultant scatter from the top view, it's obvious that there are some objects that are extending beyond the edge of the floor plate. This is because Forest uses point mode when using surfaces to determine if an object should be included in the scatter. This presents a problem, as these objects could extend through the facade. So in this step, we'll remove them using Exclude Splines. So, create a new spline that's larger than the building in the top view and convert it to an editable spline object. And I'll just move it up above the building so we can see what's going on. Go to the Modify panel and in the same spline object, draw a second closed spline that is smaller than the building's footprint. Any items that fall between these two splines will be removed. Click to add a new spline object from the scene and pick the one we just created. Then change the mode from Include to Exclude, and as you'll see, the space between these two splines defines an exclude area. If you also want to remove objects from around the core of the building, just simply add another closed spline and set the mode to Exclude. So the exclude spline technique cuts through the entire height of the building. It's not necessary to create a spline for each layer. This means it's ideal for structures that retain the same profile throughout their height. If there are only a couple of shape changes, then the easiest solution is probably to divide the building into multiple forest objects, one for each new profile. But for buildings that have highly variable profiles, like this simplified example shown here, this would mean a lot of forest objects. So for these type of buildings, instead of using splines to exclude objects, we can restrict the scatter to particular material IDs. In this example, we'll offset the floor plate to create a perimeter ring of polygons and change the material ID. But before we do that, let's apply our existing Forest Pack object to this new set of floor plates. So select the forest object and open the surface rollout. Delete the existing floor plate by selecting them one at a time in the surfaces list and clicking on delete. To add new plates, click on add multiple and select the objects named curved plates 1 all the way up to curved plates 37. Now we'll edit the plates themselves, so select them all and then add an edit poly modifier. We'll go to the polygon sub-object level and select the top polygon of each of these floor plates. You may find selecting with the ignore backfacing on from the top view is an easy way of doing this. With the poly selected, add a second edit poly modifier and activate the polygon sub-object level and turn on use stack selection. In the edit poly mode rollout, change the mode to animate. This will allow us to come back and adjust the inset at any time. Go to the edit geometry rollout and turn on preserve UVs. This will prevent the inset operation from upsetting any existing UVW mapping you might have set up. And finally, let's click on the inset settings button and then dial in an inset value. Click OK when you're done. Because we put this modifier in animate mode, we can come back and change this at any time. Now, without deselecting the polygons, add a new material modifier and set the material ID value to something different from the rest of the floor plate geometry. In this example, I'll use material ID 6. So we've set up the floor plates. Now we need to make just one change in the forest object itself. So reselect it and then open the areas rollout. Now select the surface area in the areas list and enter the material ID we just created. If necessary, you can use multiple IDs, just leave a space or a comma between them. And remember, you can go back to this floor plate at any time to adjust the offset value. Just select the edit poly modifier used to create the inset, click on settings in the edit poly mode rollout and just enter a new value. In the previous example, each floor plate was a separate surface. This may not always be possible, as you may have a more complex or a combined mesh for the internals of the building. In this case, we can use the UVW space of the surface to scatter the objects as an alternative. To demonstrate how to use UV mode, we'll use the existing Forest Pack object and go to the areas rollout and delete the surface material ID value. It doesn't work in UV mode. Go to the surface rollout and delete the existing surfaces. Next, add a new surface by clicking on the green plus and pick attached floor plates from the scene. You'll notice that when using a stack of surfaces combined into a single mesh, Forest Pack only distributes objects on the topmost polygons. Change the surface mode to UVs to scatter objects on all the floors. In UV mode, you'll notice that the scatter is exactly the same on each floor, despite the fact that randomized stacked is switched on. This is because it works differently and the UV mapping of each floor is identical. To add variation to the scatter when using UV mode, it's necessary for each floor's position in UV space to be slightly different. So to fix this, select the surface, apply an unwrap UVW modifier, open the UVW editor, and auto-pack the UV islands to give each floor a unique UV space. And now, when you close this, you'll see each floor has a unique distribution of objects. If you open the areas rollout, you'll notice that many of the features are disabled in UV mode. Consequently, it's not possible to prevent scattered objects coming too close to the exterior of the building using either splines or material IDs. So to achieve this in UV mode, we have to be a bit more inventive. And in fact, the only way to really control this is using the distribution map itself. Essentially, what's required is to create a map for each floor with a white area where you want furniture and a black area where you don't. There are any number of ways these maps could be created. You could, for example, hand paint them using viewport canvas, or bake them out using render to texture and color edge. But the important thing is that the maps must be able to be evaluated before render time in order to work correctly. In this example, I'll create a white map in UV space -1 to 2 and ensure that all the polygons that should produce furniture are mapped to this area. Anywhere outside that UV space will be black, and any polygons that are not to host furniture will be moved outside the white range into the black area. So to do this, we'll first create the map. Select the forest object, open the distribution map and click on the map slot. Select a gradient ramp and then instance it into the material editor. Edit the gradient ramp so that the colour is solid white. Then turn off tiling so that the area outside the map is black. We'll enlarge the map slightly so that it occupies a UV space of -1 to 2 by setting the U and V tiling to 0.33. That's the map done, so next we need to move any polygons that we don't want to contribute to the scatter outside this UV range. Where possible, it's good to try and maintain parametricism, so I'll do this using a UVWX form modifier. But first, let's add and inset the existing surface. To do this, select the surface and add a new edit poly modifier. Go to the polygon sub-object level and select the top polys for all of the floor plates. With the polygon still selected, add another edit poly modifier. If you want to remember what this is called at a later date, you could rename it EP Inset. Activate the polygon sub-object level and turn on Use Stack selection. In the Edit Poly mode rollout, change the mode to Animate. Again, this will allow us to come back and adjust this inset at any time. And in the Edit Geometry rollout, turn on Preserve UVs. Click on the Inset Settings button and dial in an inset value. Click OK when you're done. Remember, because we put this in Animate mode, we can come back and change it at any time. Now, without deselecting the polygons, add a third Edit Poly modifier. Go to the polygon sub-object level and press Ctrl and I to invert the selection. If you want to remember what this is for at a later date, you could rename it EP Invert. And then without deselecting these polygons, add a UVWX form operator. We can use this to move the selected polygons to a new UV space by entering a value of 5 cm in the U offset property. If you're not using real world mapping, then 0 to 1 in UV space is represented by 0 to 1 system units. And in this case, the system units are in centimeters, so we've moved the UV space of these polygons 5 tiles to the right. You'll now see that the furniture has been removed from the selected polygons. Any polygon selected by the EP Invert Edit Poly modifier will be passed up the stack to the UVWX form operator to prevent items appearing. This is ideal for selecting areas of the building in which you do not want furniture to appear, whether that's around the perimeter or whole rooms. Finally, you may also want to limit the distribution of the building to particular floors. You could do this using the technique described above by adjusting their UV space, or alternatively you can achieve this based on the height of the building. To do the latter, go to the surface rollout and turn on altitude range limited. Set a bottom value to determine the starting height of the scatter. Then set a top value to determine the end height for the scatter. You could then duplicate this forest object to add different furniture on other floors. For example, you might want floors 0 to 3 to be retail, 4 to 10 to be offices, and 11 plus residential. In some cases, it may be possible to use RailClone to create the floor plates. When using RailClone, you'll have to use UV mode, as we just discussed, but in this case, using RailClone has advantages because it allows you to parameterize the randomization of the floor plate's UVWs to create variation for each floor. This means there's no need to use a UVW unwrap modifier to manually assign each floor plate a unique UV space. In the following steps, we'll use RailClone to create a vertical array of floor plates. To do this, create a new RailClone object. Go to the Style rollout and open the Style editor. Add a new linear generator. Right click on the generator and go to Export Parameters, Geometry and X Size. Create a new numeric node, change the properties type to scene units and wire it to the exported X size property of the generator. Now create a new segment node. Go to its properties and pick rectangular floor plate from the scene. Wire the segment to the default or evenly input of the generator. If you use the evenly input, you can adjust the spacing between floors using the generator's properties rules evenly distance value. Rotate the whole RailClone object 90 degrees on the y-axis so that the building is vertical. And to use RailClone as a surface, it's necessary to turn off the instancing engine and be sure that the full mesh displays in the viewports. To do this, go to the Display rollout and turn off Use Instancing Engine and set the Display Viewport mode to Mesh. Now let's apply the forest object to this. Select the forest object and open the surfaces rollout. Delete the existing surface. Add a new surface and select the RailClone object we just created. The mode is already set to UV, so there's no need to change anything here. You'll notice that the scatter distribution is the same for each floor as it was earlier, and this is because each floor shares the same UVW space. But let's fix this with RailClone. Reselect the RailClone surface and open the style editor. Add a new UVW Xform node and wire it between the existing segment and the generator. Go to the new node's properties and turn on random offset. Then enter a value of -1 for the U and V minimum and 1 cm for the maximum. As with the UVW modifier, one scene unit equals one UV tile. By using these values, we're ensuring that the randomization keeps the UVs within the white area of the map that we created earlier in this tutorial. You should now see that the distribution is randomized on each floor. When preventing objects from penetrating the facade, we're still using UV mode, so the best way to control the scatter is using the distribution map as we described earlier. The only real difference is that now we only need to edit a single floor, because RailClone will duplicate the geometry for every level. This also explains why we make the white area of the distribution map extend well beyond the 0 to 1 UV space. If we didn't, the UVW Xform randomization effect could cause unwanted black areas to appear in the distribution map. If we look closely at the alignment of the desks in relation to the building perimeter, you can see that they're all facing the same way, irrespective of which side of the building they're on. Ideally, we'd like the desks to rotate to remain in the same alignment in relation to the building's footprint. We can't use the transform by map settings for this because the desks, chairs and computers are grouped, so they'll only rotate around their own local axis. Luckily though, we can achieve this effect by aligning the scattered objects using the surface's UVs. Here's how. UV align can be found in the surfaces rollout. It's on by default, but you can change it from here if you want to turn it on or off. To get it to work, we'll select the floor plate source geometry. There's an existing unwrap UVW modifier in the stack. Open the UV editor, and what we need to do is to make sure the outside face of the building aligns with the U axis for each side. To do this, detach each side and rotate it so that they're all the same. Now if you look at the desks, you'll notice they remain aligned with the exterior face of the building. If you swap the rectilinear floor for the circular one, you can see this effect more clearly. Instead of creating a stack of surfaces, we can use it to add a two-dimensional array of rooms around the perimeter of the building. This style uses 2 room segments, one with and one without a wall, and 4 corner segments with some different internal wall configurations. The more of these you add, the greater variation you can achieve inside the building. These rooms have already been mapped so that the perimeter UVWs are moved to the black area of the existing distribution map using the technique we've just discussed. In addition, there is a V-Ray light material on the ceiling that we can randomize in RailClone to turn lights on and off. So let's use these 6 segments to create a style. Create a brand new RailClone object, go to the display rollout and set the viewport mode to mesh and turn off use instancing engine. Open the style editor and add a new A2S generator. Set the X rotation value to 90 degrees. This will rotate the array's y-axis so that it's aligned with the world's z-axis. Now go to the generator's properties, go to the rules tab, find the X corner group and set the bevel mode to none. This will prevent the corner geometry from being sliced. Turn off align to path so that the corners will align with the preceding spline segment, they basically won't bisect the angle. And then add a new spline node and select the building spline from the scene. Wire the spline node to the generator's X-spline input. We're using a spline for the path on the X-axis, but we'll use a simple measurement for the height. To do this, we'll export the generator's Y-size parameter and wire it to a new numeric node. Change the numeric node type to scene units and enter a value of 120 meters. Next up, we'll add the segments. So create 2 segment nodes and change the properties and alignment Z value to pivot for them both. Using these, pick the 2 rooms from the scene. We want to randomize between them, so add a randomize operator and then connect these 2 new nodes to the randomize operator's inputs. To add more variety, you could also add a mirror operator and then add this to the randomize operator and wire default 1 segment to the mirror node. Wire the randomize operator to a new material operator and set the material node's properties so that it's replacing material ID 6 and randomizing it between 5 and 6. This operator is going to take all the polygons with a material ID of 6 on each segment and then randomize them between ID 5, which allocates a material with the light switched off, and ID 6, which contains a material with the lights turned on. So this node is going to give us the ability to randomize lit and unlit rooms. Just like the previous example, we want to randomize the distribution by shuffling the UVW coordinates of the floor plate. So to do this, add a new UVW XForm operator and turn on offset and set -1 for the minimum values for the U and V axis and 1 for the maximum values. And then wire the UVW XForm operator to the generator's default input. Next up, we'll add the corners. If you're using RailClone Pro, create 4 new segment nodes and change the properties alignment X and Z value to pivot. If you're a light user, just create 1 because there's a limit of 3 segments for light users, but you can still complete this style with just 1 corner variation. Use the segments you just created to pick corners 1, 2, and 3 and 4 from the scene, and then wire these to a new randomize operator. If you take a look at the corner, you can see there's a problem with overlapping segments. To resolve this, we need to add right padding to the corner segments. To do this, add a new transform operator between the randomize and the material nodes. Right click on the node and export the right padding property. Then right click on the corner's randomized node and export the X size attribute. We can now wire the X size attribute and the right padding parameter together. The corner's right padding is now exactly the same size as its dimension on the X axis. And this completes the building interior. We can now apply the forest object to it. So select the desk's forest pack object that we created earlier and open the surface rollout. Delete the existing surface and add the new RailClone object instead. You'll notice that the objects are being scattered on the ceilings and the walls. To prevent this, we need to limit the scatter to only those polygons which are facing upwards. You can do this using the limit to slope controls in the surface rollout. Turn on slope range limited and enter a maximum value of 5. We can now reuse this forest object to add the people. To do this, clone it, then go to the geometry rollout and delete all of the items except null. Click on add multiple and pick the male and female characters. Adjust their probability until you get a good distribution. A low value of 2 or 3% works quite well. Because we duplicated this forest pack object from the desks, they share exactly the same distribution points. This can result in characters stood in the middle of desks, which we don't want. So to move the grid so that the characters stand between the furniture, we can use the Transform Translate feature. Open the Transform rollout, enable translation, and enter a minimum and a maximum value of -30, or until the grids are adequately offset. While you're here, you could also turn on rotation randomization to add some more variety. With that done, we've now populated the interior of this building with people and furniture. Moreover, this entire setup is fully parametric. As a bonus to round up this tutorial, let's create a couple of RailClone styles to add a facade to this building. To maintain compatibility with the light version, we've split the facade into 2 separate RailClone objects, but they could easily be combined if you're a pro user. These styles each use 2 segments. For the windows, it's a corner and the window itself, and for the support bracing, a single diagonal and a corner. The aim with these styles is to maintain instancing support as far as possible. So to ensure this, none of the segments are sliced or bent, and the corner segments have been pre-sliced before adding them to RailClone. Here's how to use these to construct a style, and we'll start with the window. To create a new RailClone object, go to the display rollout and temporarily set the viewport mode to mesh. It's just while we create the style, and when it's used on the whole building, we'll need to set this back to adaptive mode to ensure viewport performance isn't affected by the millions of polygons RailClone can create. Now open the style editor and create a new A2S array. In the properties, set the X rotation value to 90 degrees to rotate the array's Y-axis so that it's aligned with the world's Z-axis. Still in the generator's properties, go to the rules setting and set the default mode to adaptive. This will mean that only whole segments are used, and RailClone will only add an additional window when there's sufficient space to do so. All of the windows will be subtly scaled to fill the available space without leaving gaps. Still in the properties, go to the X corner group and turn off align to path so that the corners align with the preceding spline segment. Then add a new spline node and select the same building spline from the scene. Wire this node to the generator's X spline input. Export the generator's Y size parameter and wire it to a new numeric node. Change the numeric node type to scene units and enter a value of 350 centimeters. We'll increase this value to the full height of the building once the style is completed, but it's helpful to use a smaller value while we create the style to keep the geometry nice and responsive. Now we're ready to add some segments. Create 2 new segment nodes and change the alignment on the Z axis to center. And then use these 2 segments to pick the objects named facade corner and facade window from the scene. For each segment, turn off Bend and Slice in the Deform tab. The window is going to make up the main bulk of the style, so we'll wire it to the default input, while the corner goes and the inner corner input. And then the final step is to offset the whole style so that the window moves outside of the floor plates by entering minus 14.5 centimeters for the generator's properties Y offset value. Then to create the diagonal braces, we'll use the same technique, but with the addition of a few mirror and sequence nodes to reuse a single diagonal component and create the diamond pattern. To do this, we'll clone the Windows RailClone object, rename it diagonals, and open the style editor. Select the window segment and change the geometry by picking diagonal default from the scene. Change the alignment Z to pivot. Then select the corner segment and then change its geometry by picking diagonal corner from the scene. Change the Z and X axis to pivot. These pivots on the source objects have been moved so that the segments will align correctly, and changing these options ensures that RailClone uses those pivots. We want these braces to be much further to the outside of the building, so change the generator's Y offset value to minus 103 centimeters. If we look, the corner has the same overlapping issue as the building interior did, and just like the building interior, we can fix this by adding some padding to the right of the corner segment. We'll use the size of the segment on the X-axis and add this value to the right padding. To do this, right-click on the corner segment and export the X-size attribute. Next, add a new transform operator between the segment and the generator and export its right padding parameter. Wire the segment's X-size attribute to the transform operator's right padding parameter, and finally go to the transform operator's properties and activate padding. To create the diamond pattern in the corners, wire a new sequence operator between the transform operator and the generator's inner corner input. Select the sequence operator, open its properties, and set it to increment on Y so that it sequences on that axis. Now wire a new mirror operator between the corner segment and the sequence node and change the mirror axis to Y. And to finish the corner, wire the corner segment directly to the sequence node, bypassing the mirror operator. And that's the corner finished. Now let's create the same sort of pattern for the default segment. Wire a new sequence operator between the default segment and the generator's default input. Wire the default node to the second input of the sequence operator via a new mirror node. Now create a second sequence operator and wire the existing sequence node to its first input. Change the new sequence operator to increment at Y. Wire the original sequence node to the second input of the new sequence operator via a new mirror node. Set this mirror axis to Y. And you should now have a diamond pattern. And to finish up, we'll restore the full height of the building. Before doing this, make sure you go to the display rollout for both RailClone objects and set the viewport mode to adaptive. You can then set the height of the building by going to the parameters rollout found in the modify panel. And once this is done, you're ready to render. So in this tutorial we covered a number of useful techniques for scattering objects onto stacked surfaces. Although the focus was populating the inside of buildings, it's our hope that some of these tricks will prove useful in a much wider range of applications. If you come up with an interesting project, please feel free to share it on our forums, and stay tuned for even more Forest and RailClone training coming soon. For more information about the features demonstrated in this tutorial, please check out our reference section, or visit the tutorials page for more tips and tricks videos and in-depth tutorials.